Hello, folks, and welcome back to Psychiatric Survival, and I'm your host. Today's topic is of utmost importance, and I've been compelled to make a video on this subject because I've seen on the YouTube community and over around the internet that people tend to ultimately not really understand how these drugs work at an even very basic level, and that's evidenced by some of the ways that they try to get off of their psychiatric medications. So I want to try to help the community. That's why I make these videos. I don't do this for my own, I don't do this to benefit only myself, or really, it's mostly selfless based on my own experience. I just don't want to see other people suffer. It's to bring awareness to this plight that we face. Anyone that takes psychiatric medications. So I'm gonna explain to you how these drugs work. And based on understanding the physiology behind how they function in your body, some suggestions on how to get off. Now, this is not medical advice. I'm going to make that disclaimer. I'm not a doctor or a medical doctor, and I'm not telling you what to do. I'm just giving you some advice so that you can provide this to your doctor in order to determine whether or not he or she even understands their own practice. Okay, so let's go over the basics. When a drug is swallowed, it is later absorbed through the stomach and the small intestine, right? So you take your 20 milligrams of Lexapro, you swallow it in the morning, and then around roughly a few hours later, 3 to 4 hours later, that blood is dissolved in the fluid in your digestive system and absorbed through the lining of the small intestine and the stomach, depending on the drug that you take. Some of them have time release mechanisms that allow it to be more slowly released as it enters the intestine. But for the most part, they're all absorbed in these two locations, as you can see in this picture. Now, once the drugs dissolved into the circulation, it's into the blood, basically. It is then transported to the brain. And it crosses the blood-brain barrier and starts to wreak absolute havoc on your central nervous system within several hours after consumption. So, although the drugs and the doctors tend to tell you that they it takes several weeks for these drugs to work, that is completely untrue. Within hours after consuming these drugs, they begin to have effects on the neurotransmitters in your brain. And the blood-brain barriers, and if you just take a look at this picture down here, the brain is loaded with blood vessels, and the drugs that you take are circulating around in your blood throughout the entire day, and for days afterwards. Now, after the drug influences your brain chemistry, it continues to float around in the circulation as well. It doesn't just go into your brain and then disappear. This drug continues to be present in your circulation, and because the circulation is a closed circuit, it passes through the organs multiple times throughout the day. And one of those organs that it passes through is the liver. So the drug is treated as a toxin by the liver and then metabolized by enzymes, probably the P450 complex of enzymes, over time, and then the drug is basically, it goes from the drug and becomes an inactive version of the drug. It takes away one of the subgroups from the molecule and renders it ineffective at what it should be, and then it is excreted in the urine. And that's why you get when you get tested for if you apply for a government job, they test your urine because you can actually tell what kind of drug someone's taking by what's present in their urine. So over time, the drug that's circulating in your blood and affecting your brain does get destroyed and is treated like a toxin. But it basically is a toxin and the body is trying to get rid of it. But in the meantime, the body is undergoing profound changes. Now before I go into those changes, let's look at how the drug is excreted from your body, because this is absolutely critical for you to understand. If you don't pay attention to anything else in this talk, please pay attention to this. Drug half-life. So if you look on the graph here, the x-axis is time in hours, and this is just a generalization, and the y-axis is blood concentration. You see when you take the drug, within the first hour or so, now this is just a hypothetical example, but let's go with it, you reach maximum concentration. So it's quick. And then over time, as the liver detoxes the drug out of your blood, you see this exponential decrease in drug concentration. So after every hour, after a certain amount of time, this is key, listen to this, after X amount of time, half of the drug is removed from your body. And whatever that time is relative to the drug that you take. So in this example, it's every hour. But for psych meds, let's take a look at the typical antidepressants. Now, these are all the generic names. But if you look at these drugs here, let's look. This duloxetine is Cymbalta, 12 hours. So it takes 12 hours from the time of absorption, from when you first absorb the drug, for half of the dose to be gone. Let's look at venlafaxine, that's Effexor, 10 hours. Paroxetine, that's Paxil, 21 hours. Fluvoxamine, 9 to 20 hours. This is a pretty common. Citalopram, 35 hours. Amitriptyline, 25 hours. Sertraline, that's Zoloft, 83 hours. That's a long one. That's very long. That's actually that's like almost an order of magnitude longer than the Effexor and the Cymbalta and the other SNRIs. And then if you look here down at the bottom, it's fluoxetine. That's Prozac. That has by far the longest half-life, 240 hours. That means it takes months for it to get out of your body. But for most of these drugs, now this isn't all of them, for most of them it's about 1 day. So it's important to understand that over time you build a steady state of quantity of this drug in your bloodstream. So as you can see on the graph on the left, as soon as you take the drug, you undergo half-life, and then the next day, at some point in the next day, you re-ingest the drug, and now your blood level spikes to a new level, decreases, then increases again, decreases, then increases. But over time, you build this steady state. And as you can see on the right-hand graph, you have that same effect. It decreases, increases, decreases, increases. So, especially for these short half-life drugs, like Effexor and Cymbalta and Pristiq and all those drugs, you're going through withdrawals before you take your next dose, because the drug is so short in its half-life. And, I honestly think it's very irresponsible for these drug companies to even release a drug that has a half-life of 12 hours. For comparison, heroin has a 12-hour half-life. So you're going through detox as you would if you were to take heroin when you're taking these drugs. So they have very short half-lives. So that has profound implications when it comes to getting off of these drugs. But let's go into the effects. So let's say you've been taking these drugs and now you have a steady state of let's say, Effexor in your blood. Well, in the short term, you experience euphoria. And you also have other side effects. You have constipation, you have nausea, etc., etc. As the synapse is flooded with serotonin. It's a massive flooding of serotonin. Some 80% of your serotonin reuptake is immediately inhibited. So you have a huge amount of serotonin rapidly. Within just 1 day, all of a sudden you have this change. And in addition to that, other neurotransmitters are also flooding their synapses. So if you look at this graph, look at this image here, serotonin is released, it's flooding the synapse, but SSRIs are blocking the reuptake. So the synapse is flooding with serotonin, and as a result, the postsynaptic membrane has a massive increase in cell signaling. The brain does not like this. This is a warning sign to the brain. The brain and the central nervous system go in panic mode when they see this. They do not say, oh, okay, let's keep going like this. No, because too high of stimulation can lead to all sorts of bad things, ranging from cell death to heart attacks to all sorts of bad things. For example, one bad thing that can happen if you have too much serotonin, if your body reacts too profoundly to these drugs, is serotonin syndrome, which can cause death. So the body immediately begins to compensate for this increase in serotonin. And it takes some time for these compensations to take effect. So after a week or two, your neurons are undergo long-term physical, structural changes. By both, one, by downregulating receptors, and two, these are the main ways, there's other ways as well, and two, by changing the shape of the cells themselves. For example, when you change the shape of the cells, the dendrites throughout the entire brain may change shape, twist around to accommodate new cellular activity. So here you have one neuron out of billions that you have in your brain. These are the dendrites right here, those ones that are shaded in purple. And over time, because the way the brain is now that you have a whole bunch of new cellular activity, neurotransmitters are changing the way that they're functioning, the brain is trying very desperately to cope for this toxic effect from the psychiatric medications. And what it does is it literally twists and changes the physical shape of the neurons in your brain. And there's actually a study that has proven that. This is the most common way. This is how most drugs work, the receptor downregulation, and it also works with SSRIs. So receptors downregulated throughout the entire nervous system, not just in the brain, anywhere where 5-HT neurons or serotonin neurons are present. And this is also true for the neurons that these drugs affect inadvertently, like norepinephrine and acetylcholine. Anyway, the receptors are literally destroyed by cell lysosomes. So there's usually millions of these like proteins up. You see up on the top that blue thing, that's a protein, and the cell purposely destroys these proteins because it wants to reduce cell signaling. It doesn't like all that serotonin in the synapse. It needs to reduce cell signaling to protect itself. So it does this rather rapidly. Within a couple of weeks, a number of the receptors are downregulated so that normal cell signaling is returned to baseline. Now, there are downstream unintended consequences that also occur when you take antidepressants. So those two I showed are just the immediate effects, but the brain is in crisis mode. It is being affected profoundly by all directions. One way is hormonal changes in estrogen, testosterone, cortisol, aldosterone, growth hormone, etc., etc. They all in turn affect numerous cellular processes in nearly every single part of the body, from the genitals to the feet to the eyes to the liver to the stomach to the kidney to the brain to the way you sweat to your appetite. Everything is suddenly changing because the body is in panic mode because of this toxin that has been introduced. Other neurotransmitters such as dopamine, acetylcholine, norepinephrine are also altered, changing numerous processes throughout the body and changing the neuronal structures accordingly. So a lot of changes are suddenly occurring. Antidepressants strongly influence most hormones. Now, this is not very well understood, and I would be honestly surprised if your doctor acknowledged this as a fact, but it's true. Researchers understand this. And it does this by acting on the hypothalamus-pituitary axis, among others, especially the... okay, so let's look at this. So serotonin neurons in the hypothalamus axis. So studies have shown that the serotonin system and the limbic hypothalamic pituitary adrenal axis are linked in a variety of ways. Uh-oh. Well, that's not good, is it? No, it's absolutely terrible. The consequences are profound. So anyway, you have... I'm not going to go over every little detail of this figure, but the purpose is to show you that the raphe nucleus and the serotonin neurons all interact with the endocrine system. The central nervous system and the endocrine system are intrinsically linked. You can't just increase serotonin and not influence hormones. That's not how the body works. You don't just throw a magic bullet into your brain and expect serotonin to be increased and get rid of depression without dramatically affecting every other part of the body. So let's take a look. Antidepressants and other psych meds too, the antipsychotics are particularly known for this, but basically any drug you take affects the hormones. So they affect most hormones in the body. It doesn't just affect one. It doesn't just change your thyroid hormone. It changes absolutely everything about you. Now let's just take a look at this. So it affects the trophic hormones, the hormones that are then released and affect the individual endocrine glands downstream. So this is just some of the trophic: ACTH, THS, LH, FSH, PRL, growth hormone, and it affects all these organs. It affects everything from lactation to the thyroid to the adrenal glands. Now, the adrenal glands, you don't want to mess with the adrenal glands because they affect a lot of crap in your body. And if you start messing with the adrenal glands, you're in big trouble. Guess what the antidepressants do? They mess with the adrenal glands. They also mess with the reproductive organs and the liver. Now, the liver is something you do not want to mess around with, but it is affected. All these hormones potentially affect cortisol, which affects everything, basically. Cortisol is a powerhouse endocrine hormone that you do not want to play around with. Another one are the thyroid hormones. You do not want to mess with these hormones, but antidepressants and other psych meds do in profound ways too. Testosterone inhibits spermagenesis, and estradiol, progesterone, and all sorts of other things affect ovulation. So these drugs are a complete mess. Oh, but that's not all. Most antidepressants both directly and indirectly influence at least these four major neurotransmitters. Not only serotonin, but also dopamine, norepinephrine, and acetylcholine. Now, I need to caveat here by saying, yes, I know that drugs like Effexor affect norepinephrine more strongly than serotonin. But even drugs like Paxil, which mostly affects serotonin, affect all these other four neurotransmitters as well. Let's see what that might do. Well, serotonin, dopamine, and norepinephrine and acetylcholine affect every single area of the brain. So let's look at this. Dopamine, these are the neurons that proceed throughout the brain. These are actually long fibrous cells that extend throughout the brain. As you can see, dopamine, you know, if you just take something like cocaine, which affects dopamine very profoundly, it's going to affect the whole frontal lobe of the brain. But antidepressants also affect dopamine in downstream ways, and so it affects these brain regions as well. Norepinephrine. This is a really profound one, norepinephrine. It affects only the central nervous system, but also the peripheral nervous system. Just look at this graph. Look at all the brain regions that are affected by norepinephrine. And ask yourselves, do you think it's safe to take a drug that affects all these areas of the brain? Let's look at another one. Serotonin. Now this is the serotonin, right? Now look at how those neurotransmitters, look at how these neurons affect every single part of the brain, from the brainstem up to the upper brain, down to the medulla oblongata, the whole entire brain, the emotions, the instincts, the conscious thought, self-reflection, everything is being affected. Let's look at acetylcholine. Now this is another major drug. It's called if you ever hear the term cholinergic or anticholinergic, that's acetylcholine. And now antidepressants definitely affect acetylcholine. This isn't a question. This is definite. Look at all the areas of the brain that these neurons project to. A lot. So this is just what here's a small fraction of the functions that just serotonin alone affects. It's not just depression. The chemical imbalance theory is complete bogus nonsense. It's been disproved for 30 plus years. Just look at all the effects. Addiction, aggression, anxiety, appetite, autoreceptor, blood pressure, cardiovascular function, emesis, heart rate, impulsivity, memory, mood, nausea, nociception, penile erection, pupil dilation, respiration, sexual behavior, sleep, sociability, thermoregulation, vasoconstriction, cardiovascular function, GI motility. I could go on and on. That's just serotonin. Norepinephrine, acetylcholine, and dopamine affect hundreds more functions. So you may be wondering now, after seeing this is just a general overview, your expression may look rather confused, right? Now let me. It's not all. Let me continue. There are more effects that these drugs have. Let's look at the gut. The gut is actually where most of the serotonin in the body is produced. Serotonin 5-HT in the human gut affects intestinal transit, colon tone. So basically what that means is constipation is quite common because the enteric nervous system is controlled by release of serotonin. So although the drug companies market to you saying, oh, serotonin actually just affects mood. No, it actually affects mostly your gut and all sorts of other parts of your brain. Mood is just one thousandth of what serotonin affects. The other 999 functions are also affected. So a secretion of hormones. I mean, it's absurd how many effects that the GI tract, how many effects serotonin has in the GI tract. So is it any wonder why people are chronically constipated? They can't. Their appetite changes. They're gaining weight. They're eating things that you don't usually eat, or they start starving themselves and becoming anorexic. No, it's not really any small wonder. Oh, and it also affects all of the sensory nerves in your body. What does that mean? Oh, well, I mean all the nerves that you basically use to communicate with the world and communicate with your loved ones. The C fibers that affect the sensory touch and your genitalia and your face and everything. Basically everything you use to perceive the world. Your eyes too. Your eyes are the sensory neurons in your eyes are also, the optic nerves are also affected by serotonin, norepinephrine, acetylcholine, especially norepinephrine and acetylcholine. And the autonomic nervous system, which controls virtually every single part of your entire body, is profoundly affected by antidepressants and other psychiatric medications. Just look at this is a basic fight and flight response picture, but just look at all the organ systems that are affected by that stupid little pill that we take in the morning. I don't take them anymore, but some people take. Everything. It affects everything, people. The norepinephrine and acetylcholine that are downstream affected by antidepressants affect every single part of your entire body, especially the functions that are required to live. If you look in your packet on the side effects of antidepressants, you'll see cardiovascular, like heart attack and stuff like that. How is that even possible? Well, it's possible because, look, heartbeat is controlled by the parasympathetic and sympathetic neurons. What neurotransmitter controls heartbeat? Oh, norepinephrine and acetylcholine. And if something just happens to go wrong, if you're somebody that just doesn't have as much of the hormone the enzyme that breaks down the drug in your liver and reduces the blood concentration over time, you can have a more profound effect. And the amount of enzyme that people have to break down these drugs is highly variable. But they're giving standard doses to people, just assuming everyone's the same, which just profoundly demonstrates their ignorance. So, this is my expression. I mean, these drugs are fucked up. It's incredible. It's astounding. The question you should be asking yourself is, what the fuck?